Hello everyone. So let's continue working on the events and state manipulation where we left in the previous video. Let's start working on this function, update player pieces. Now this function is a little bit complex because working on this function we will end up creating a lot of other functions. And this function will have a lot of nested if-else conditions, which makes it a little bit complex. So first of all, let's pull the moves variable from the state. And in the first condition, we will check if we have anything in the moves array. Then we will do something about this. Otherwise, we will just set state. Now inside this condition, we need to check first if the player is not finished. We are already passing the player to this function. We will do something in this condition, and if the player is finished, we will just do the same thing as over here. But we also need to make the moves array empty. Now inside this if condition, we have some more if-else conditions. That is, we have some more conditions to check for before doing anything. And let's see what those conditions are. The first condition is if the player has options for moves. Now the example of this, if the player rolls the dice and we have 6, so the player can pick up any of the 4 pieces. So the player has option to pick up any of the piece to move. And for example, if the player has multiple pieces out of home and one piece is at this position, R1, and the another piece is at this position, R2, and let's say the player rolls the dice and gets any number. So the player has options to move either of the pieces. So that's the condition for that. And another condition is else if the player has single possible move. Now an example for this condition is going to be, suppose the red player has 3 of its pieces at these 3 positions, R18, R17 and R16, and one of the piece is at R1, and the player gets 5. So the player can only move the piece which is at the position R1. So this function will return that particular piece and the respective move in case we have multiple moves. Else, we will do the same thing. As in this condition. Now for this condition, we need to create a state field, animate for selection, and we will be updating that to true in this condition, like this. So if we are making this true over here, we need to make it false back in these conditions. let's add this into the state. Now inside this if condition, we further have if-else conditions. The condition we are going to be checking is if the player has single unfinished piece. We will be creating all these functions that we are calling over here, like player has single unfinished piece, player has single possible move, and player has option for moves, etc. But let's first complete this function, and inside this condition we will get the single possible move object. With the function get single possible move. So this function will be returning an object, single possible move, that will contain the piece and the respective move. So we will check if the object returned by this function is not null, and then we will call the function move piece by position, passing the piece and the move from the object returned. But before we call this function, we need to remove the moves from the moves array that we are using in this function. And in the else condition, again we have if-else condition. And I promise that's the last if-else condition inside this function. If moves.length equals to 1, else we will just update the state, put animate for selection to true. And if we have only one move, in the moves array, so we need the piece that we need to move. And then we will call the function move piece by position, passing the piece and the move. Now let's create all these functions: move piece position, get piece with possible moves, get single possible move, player has single unfinished piece. Let's create all these functions one by one. Let's create this function player has options for move. Now this function we will call another function, which will return the count of move options. For the player, and then just return if the count of move option is greater than 1. Now let's create this function that will return the count of move options. Let's pull all the pieces from the player. 1, 2, 3. Pieces. And moves from the state. Let's create a boolean has 6, and its value is going to be if moves.filter move equals to 6, and if this so this is going to be true if we have any 6 in the moves array. Now let's create a variable count of options. And initialize it with 0. Now we will create another function within this function, passing it the position of each piece, that is 1.position, 2.position, 3.position. And the function will return true if the piece with that position can be moved with any of the moves that we have in this moves array. So if the function returns true, we will increment the count of options with 1. Otherwise, if it returns false, we will do nothing. And in the end, we will return the count of options. Now let's create this function. Now inside this function we have some conditions to check for. First, if position equals to finished, then return false. And if position equals to home and we do not have any 6 in the moves, return false. Let's change the condition. If this is true, has 6, return true. Now let's create a variable is move possible. Initialize to false and return is move possible. But before we return, we need to do some work. Let's create a variable position to check for. So if the position is R1, this will return 1. If the position is R2, this will return 2. And if the position is R15, this will return 15. Now for each move in the moves array, first we will check if this variable is still false. And inside this condition, we need to find out what are the possible positions that we have. So if the move is 1, we can have any possible position. So even at this position, the move 1 is possible. But if the move equals to 2, so if the move equals to 2, then at this position, we cannot make the move of 2. So the possible position is going to be 17. Similarly, we need to check for 3. Now that we have the possible position, so if we have the possible position for the is move possible to be true, the position to check for must be less than or equals to possible position. We also need to check for 6. So after this executes, the variable is move possible is going to be true if these conditions are met. Now let's create this function player has single possible move. And this function is going to be similar to player has options for moves, except for one change. We will return count move option equals to 1. Now let's create this function. Player has single unfinished piece. So in this function we are going to use the pieces of player. Let's create a variable count of unfinished pieces. Initialize it to 0. And for each piece we will check if the piece is unfinished. We will increment this variable. Otherwise we will not do anything. And we will check if count of unfinished pieces equals to 1. Then it will return true. Now let's create this function, get single possible move. Now this function is somewhat similar to this one, get count move options, with slight modifications. So let's copy and paste whatever we have inside this. Now this function returns an object that contains the piece as well as the possible move instead of the count. So let's modify this function. If this condition is true, we will return an object with move equals to possible move, and piece equals to otherwise return undefined. Now let's work on this function, get piece with possible move. So this function also works the same way with a slight change, so we can copy and paste the same code. So this time we don't need this variable possible move. We will just return the piece instead of this object. Actually, this variable possible move should be defined outside the function is possible move. So this function is only going to update this variable, which is outside the function. Now the only function left in this function update player pieces is move piece by position. So let's work on this function. So we are getting the piece and the move. So this is the function where we will be implementing the logic to update the position of the piece with respect to the move passed to it. So for example, the piece is at position R5 and you have moved 2. The new position is going to be R7. Similarly, if the position is R9 and you get 5, the new position is going to be Y1 in case it's not yellow. But if it's yellow, the new position is going to be Y15. So let's work on this function to achieve this functionality. And yes, this function is also going to be somewhat complex. And this function will also have a lot of if-else conditions. So let's start by creating a variable, new position, initialize it to empty string. And let's get the position of the piece. So this is going to be either R for red pieces or Y for yellow pieces, or G for green pieces, or B for blue pieces. So let's create the first condition. If piece dot position equals to home and move equals to 6. The new position is going to be piece dot color equals to red. If this is true, the new position is going to be R1. If it's yellow, the new position is going to be. So if the move is 6 and the piece is at home, then the new position is going to be either R1 if the color is red, and if it's yellow, the new position is going to be Y1. If it's green, the new position is going to be G1, and if it's blue, the new position is going to be B1. The other two conditions are else if position is less than or equals to 13. Otherwise, else. So these are the other two conditions. Either the position is less than or equals to 13, so it's not going to be any of these. And these. So in this case, if the position is less than or equals to 13, now inside this condition, we have furthermore conditions to check. So if the cell area indicator is equals to blue, B, and piece.color equals to red, if this is true, or this is true, if it's R and the color is yellow, or if it's Y and the color is green, or G, and the color is blue. In all these conditions, remember, all we care about in this function is to find out the new position. So to find out the new position, we yet have another condition. So if the current position plus move that we have to make, if it's less than 12, if it's less than or equals to 12, then the new position is going to be cell area indicator plus position plus move. So these both integers will add and then will concatenate to this cell area indicator to make the new position. So suppose we have a yellow piece at this position R9, and we have a move of 3, 1, 2, 3. The new position is going to be R12 as per this condition. If the position plus move is less than or equals to 12, so that's how we are going to make the new position. So the reason for this is that we don't want the yellow piece to start another round. So if it's less than or equals to 12, that's how we calculate the new position. Else, if it's more than that, so if it is more than that, so in this condition, if the updated position is equals to 19, the new position is going to be finished. So if the yellow piece is at this position R12 and we have a 6, then the position, which is 12 plus 6, is going to be 18, and that's why we are adding 1. So in this case, if the updated position is equals to 19, then the new position is going to be finished, because at this position, if the yellow piece gets a 6, then obviously the new position is going to be finished. Otherwise, we need to update the cell area indicator. If this is true, the next cell area indicator, the updated cell area indicator, is going to be if it's R, it's going to be Y. So if the yellow piece is at this position, after a move, let's say 1, after one move, it's going to be at this position. The cell area is going to be Y. Similarly, if cell area indicator, this is equals to y. The next cell area indicator, updated cell area indicator is going to be g. And if cell area indicator is equals to green, the updated cell area indicator is going to be b. And if cell area indicator equals to b, the updated area indicator is going to be r. Now the new position is going to be updated cell area indicator plus updated position. Now let's work on the else part of this condition. So if we are not inside this if condition, so the first condition is going to be the same. But this time we are going to be checking for less than or equals to 13. So previously the case was a yellow piece at this position R9. Now let's assume the piece is red. So the piece can move beyond 12 to 13 as well. So the new position is going to be, if position plus move is less than or equals to 13, the new position is going to be just cell area indicator, the current, and adding these two, position plus move, and then concatenating to the current cell area indicator. Otherwise, we will need to update the cell area indicator. So we are subtracting minus 13 because let's say the red piece is at this position, R13, and we have a move of 1. So then the new position is going to be position plus move minus 13. So 13 plus 1 equals to 14, minus 13 equals to 1. So the new position is going to be 1, and the cell area indicator is going to be changed from R to Y, like this. It's going to be, let's copy and paste the same thing. Now the new position is going to be updated cell area indicator plus new position, next position. Now this is the condition if the position of piece is somewhere between these cells or these. So let's say the yellow piece is at position 16 and the move is 3. The current position plus move is going to be 19, which is equals to finish. So let's code this condition. If position plus move is less than or equals to 19, only then we are going to update the position. Otherwise, we cannot update. So let's say the piece is at position 16 and you get 6, so you cannot move this piece. If position plus move equals to 19, the new position is going to be finished. Else, new position is going to be cell area indicator plus position plus move. So now at this point we have the new position. we have the new position no matter what case we encounter. So if we have new position is not equals to empty, if we have an updated position, we will update the position of piece. And we also need an update time for this piece. The reason we need this update time is, suppose we have a red piece over here and we have a yellow piece over here, and it's yellow's turn and the yellow player rolls the dice and gets 2. So this piece, yellow piece, will move to this position where we already have a red piece. So at this position, at this cell position, the game should render a yellow piece on top of the red piece. So for that purpose, we need this update time, which will be used by the cellbox component to render the latest one on top. So let's update the state with this update time. Now that we have the position of piece updated, let's update the state. And after we update the state, we will call a function. We will first check if we still have any moves in the state. We will call the function update player pieces, passing the player, but we first need to get the player from the state. Else if state dot moves dot length equals to 0, this is true, or this dot player is finished. We need to update the state. But there is one thing that we need to do now. Before we update this state, we also need to consider the case of bonus. That is, suppose we have a red piece at this position and a yellow piece at R6, and it's yellow's turn and the yellow gets 2. So the yellow piece will eat the red piece, moving the red piece to home and getting a bonus of another turn. So the yellow piece will still be able to roll the dice. So for this purpose, we need to check in a condition. We need to create a function did get bonus. With new position. And we also need to check if this player is not finished yet. If this is true, then we will do something. Otherwise, we will do this. Now, in this case, we need to create a state field bonus count. So let's first create the state field bonus count, initialized to 0. And we will get count from this .state.bonus count. We should add, and then we will update the state. With the new count, and after the state is updated, we will do the same thing that we did over here. Now we need to create this function did get bonus with new position. So in this function, first we will check if the piece, the position, equals to finished. Return true. Because when any cell completes a round, the player is allowed one more move. Because when the cell is finished, the player gets a bonus and can roll the dice once more, in case the player is not yet finished. And we are already checking for this condition if this player is not finished. There are some specific cells where the piece never gets a bonus, and those are R1, R9, Y1, Y9, G1, G9, B1, and B9. So in all these cases, we need to check if the new position of the piece matches an existing piece of any player, then it will return true. So let's pull all the players, red, blue, yellow, green, from the state. And for each player, we will call this function if check if position matches existing piece, and we will pass the piece and the player. So this function will return true if the position of this piece matches with the position of any piece of this player. Then it will return true. But we also need to check and piece dot color is not equals to yellow Now let's create this function. Let's define a variable position matched initialized to false. So if piece dot position equals to 1 dot position 1 dot position equals to home, since the position is now taken by this piece, and position matched equals to true. Now let's update this function getNextTurn. Since we have implemented the bonus count, before updating the turn, we need to check if we have bonus count in the state. And we will return if the player is not finished. Well, actually, this function should return turn instead of true. Now you might be thinking we have created so many functions without testing a single of them. Well, bear with me for some more time as we will be testing all of these functions. with all the scenarios very soon. So I'll see you in the next video.